Proxima b, an Earth-like exoplanet in our immediate cosmic neighborhood, has attracted the attention of astronomers and space enthusiasts since its discovery. This fascinating planet orbiting the star Proxima Centauri provides key information about living conditions on other worlds, and we may have found life. The James Webb Telescope now provides the clearest image of Proxima b, and it's amazing. The superworld Proxima b is a fascinating exoplanet orbiting the star Proxima Centauri, just 4.2 light-years away from us. Two things make this planet a truly extraordinary object: its similarity to Earth and its proximity to us. Imagine we get the final proof that it's home to an extraterrestrial civilization far away in space. We would have no way of making contact. Signals would take hundreds or thousands of years. But we could send radio signals to Proxima b that could be heard and answered in a comparatively short time. The planet was first discovered in 2016, and Proxima b was one of the first candidates for the discovery of extraterrestrial life. Its orbit lies in the habitable zone of its star, and thus in a region where conditions could potentially allow liquid water on the planet's surface. The idea that Proxima b could be a world with oceans, an atmosphere, and perhaps even life did not just captivate scientists. After the discovery was made public, the news went into overdrive, and millions of people showed enthusiasm for this strange world in our cosmic neighborhood. Although Proxima b is much closer to its star than the Earth is to the Sun, it's capable of supporting organic life. The star Proxima Centauri is a small red dwarf star, and therefore much cooler than our Sun. Proxima b may have conditions that are so similar to those on Earth that this planet can be described as a so-called super-Earth. Could this distant planet be a future settlement site for humans if the Earth becomes uninhabitable? All hopes of answering these questions now lie with the James Webb Space Telescope, as this super telescope can examine exoplanets more precisely than any other telescope before it. What details could James Webb discover? The James Webb Space Telescope, or JWST for short, is a technological marvel that sets completely new limits in the exploration of the cosmos. With its cutting-edge technology and ultrafine instruments, it has been specially designed to reveal the deepest secrets of the universe and unravel the greatest mysteries of cosmology. Detecting exoplanets and searching for their similarity to Earth is one of the three main objectives of the James Webb mission. Of course, this also includes the detailed observation of Proxima b. One of the outstanding features of the JWST is its huge primary mirror, consisting of 18 honeycomb-like segments with a diameter of 6.5 meters. This mirror is significantly larger than that of the Hubble Space Telescope and enables the telescope to capture much fainter and more distant objects. The size of the mirrors is crucial when it comes to collecting extremely weak light pulses, and this in turn increases the resolution and sensitivity of the telescope many times over. Whether it's the first stars and galaxies in the cosmos or the faint light pulses scattered by exoplanets, James Webb captures these minimal light emissions perfectly and assembles them into a sharp image for the first time. Of course, exoplanets do not emit any light of their own. They only reflect the light of their stars to a certain extent. Exoplanets are extremely small dots in the vastness of the cosmos, where even stars become dots. We would not be able to see them at all if two circumstances did not reveal their existence. Firstly, they slightly eclipse their star when they pass in front of it, and they also minimally alter the gravity, and thus the rotational orbit of their stars due to their own gravity. Astronomers and engineers have developed telescopes, such as Kepler specifically to detect these tiny deviations. Although it has been able to detect hundreds of exoplanets in the course of its operating time, it has not yet been possible to analyze the planet's surroundings more closely. This is now changing with the JWST. The new super telescope works with four main instruments: the near-infrared camera, NIRCam, the near-infrared spectrograph, NIRSpec, the near-infrared imager and slitless spectrograph, NIRIS, and the mid-infrared instrument, MIRI. For the first time, they are able to capture and precisely analyze an incredible spectrum of different wavelength ranges of light, from visible light to mid-infrared. These instruments can collect light even from distant or very dark planets and detect evidence of elements and various molecules in the wavelengths of light. These technologies can find out which exoplanets even have an atmosphere, show signs of rock, vital water, or oxygen. We will even be able to determine the approximate temperatures of an exoplanet. In IRCam, the main camera system of the JWST, will play a crucial role in the study of exoplanets like Proxima b. It's perfectly suited for transit observations, where the brightness of a star is measured as a planet passes in front of it. These measurements can also provide information about the planet's atmosphere. NIRSpec provides the ability to split the light from an object into its different wavelengths to determine its chemical composition, temperature, and other properties. This will be crucial for analyzing the atmosphere of Proxima b and looking for chemical signatures indicative of life. MIRI captures light in the mid-infrared range and makes it possible to observe warmer objects in the universe. MIRI can do something else that will fascinate you. This ultrafine measuring instrument could detect artificial light signals emanating from Proxima b. Although MIRI could not detect a single light bulb burning somewhere in an alien household, light emissions from larger cities or other strong light sources, such as the lighting of industrial plants or airports, would be no problem for this instrument. The combination of these instruments, together with the enormous light-gathering capability of the primary mirror, makes the JWST a superstar among telescopes. The ability to capture fine details on exoplanets like Proxima b and possibly even detect signs of artificial lights or other evidence of advanced civilizations takes us a huge step forward in the search for life in space. With the JWST, we are now entering a whole new era of astronomy, and we are finally getting answers to some of our oldest questions. The first target, LHS 475b. On August 31, 2022, the James Webb Space Telescope used its near-infrared spectrograph to observe the exoplanet LHS 475b. This made LHS 475b the first exoplanet to be officially confirmed by the JWST. Confirmed, in this case, means that the measurements provided absolute certainty for the first time that LHS 475b really exists, and that it is an exoplanet. LHS 475b would also have the makings of a super-Earth. It's a small rocky planet that's almost exactly the same size as our Earth, and is only 41 light-years away from us. Interestingly, LHS 475b is